So we've already distinguished between combinations and permutations. Remember, permutations are like what we would call a combination lock. It really should be called a permutation lock. It's where order matters. Now, combinations are where order doesn't matter. So if we're picking the top 3 students out of a class of 54 graduates, order doesn't matter, right? It doesn't matter if you are number 1, if you're picked first, if you're picked third, you're still considered all the top 3, right? So that would be a combination. So there are 2 different types of combinations, just like there's 2 different types of permutations. For one of them, repetition is allowed. So, like that would be you pick something and then you put it back. And so then you have the chance of picking it a second time. And then the other one, repetition's not allowed. So that would be like lottery winners or like people who are getting chosen for the top position in a class. You can't pick someone twice for that. You can't be in the top 3 twice. So combinations with repetition we're not actually going to talk about in this in this class. That's more for like a full-on statistics class that we might talk about it, but not in Algebra 2. So we're going to talk about combinations without repetition. These are things like lottery winners. So in the lottery, it doesn't really matter if you get the numbers in the same order as they pick it out, as long as you get the same numbers, right? So combinations, not permutations, because order doesn't matter. So this is the way to explain it. And I hope this doesn't blow your brains too badly, but it's really, it's not terrible. So we know how to figure out permutations and we understand the logic behind them. We understand that we use that counting principle to multiply, 10 times 9 times 8 times 7 times 6. We understand how to do that, okay? So basically with a combination, what we do is we figure out the permutation. And then we divide it by all the different ways that those things that we selected could be ordered. For example, in our pool ball example, we had the permutations. There are 3,360 permutations that could be formed out of those 16 pool balls. But we know that if we pick out ball number 1, 2, 3, in permutations, that's different than if we pick out ball 2, 1, 3 or 3, 2, 1. Those are all different combinations, but those are all different permutations. In combinations, if I pick out 1, 2, and 3, it doesn't matter what order I picked them out in, they're all the same, okay? So if I list those with a permutation, there are 6 different ways that I could pull those 3 balls out, right, in order. But since order doesn't matter, there's only one way that I could combine those, right? Because this is like the top 3 students. It doesn't matter if you're told that you're in the top 3 first, or if you're told last, you're still in the top 3, right? So basically what we have to do is we have to take the permutations and we have to divide it by the number of times that we could possibly arrange those numbers that we pulled out. So how many different ways could we arrange the numbers 1, 2, and 3? Let's go back to our idea of the fundamental counting principle. Well, the first time I could pick 1. I could pick 1 digit, so I would have 3 options, right? And then the second time I would have 2 options, and the third time I would pick 1 option. So this would be a permutation with 3 things, picking all 3 of them. So there are 6 different ways that I could pick that, or 3 factorial ways, okay? So we take our permutation, which was 16 factorial divided by 13 factorial. And now we need to divide out all the different ways, all of these extra ways that we could arrange those numbers, right? Well, that was 3 factorial ways, right? There's 3 factorial. So this is the combinations formula. You'll notice that we have fewer combinations than we do have permutations because order doesn't matter. So there's going to be a lot fewer options. So this is how we would write that. This is our permutations formula, n factorial over n minus r factorial. That's our permutations. And then we divide it by how many ways we can arrange our objects. Okay, so we would divide it by r factorial. So in the end, we end up with n factorial over r factorial times n minus r factorial. So that's our formula right there. And combinations are so important and so common that you actually can write them. They have a special notation that you often see, and it's these big parentheses with n on the top and r on the bottom. So remember, n is the number of things we choose from, and r is the number of them that we choose. So we actually say n choose r, or 16 choose 3. That's actually like a notation that people use in math. So there's some other notations that you might see, just like in permutations. Sometimes you're going to see this notation, but instead of a P, it's going to be a C because we're talking about combinations. So then you might also see it here with the N and the R on either side of the C. Again, this is the one I see. These two are actually the ones I see most often, where you have the N numbers of things we're picking from, and the R is how many things we pick. Or you're going to see this one. So in the pool ball example, you might see it written in any of these ways, right? You might see C, combination 16, choose 3. You might see 16, choose 3. You might see 16, choose 3. Or you might see 16, choose 3. These are all different ways to write our pool ball example. Hi, buddy. You know I'm recording a video? Hi. Hang on for just a minute, okay? And then we could do 16 factorial. That would be 16 factorial over 3 factorial. And then n minus r, so that's 16 minus 3, which is 13 factorial. Okay, so this is how we would do it. And now let's figure out how to do that in a calculator. I'm going to show you on this calculator. Both calculators work the same. You just need to put the factorial in. Okay, so in this case, we had 16 factorial, math, go over to probability, go down to factorial, divided by, okay, now we have 3 factorial times 13 factorial. Remember, those are both on the bottom. So remember that our calculator is really actually very good at order of operations, so it's always going to do it in the order that we tell it to do it. And so if we do it this way, it's actually going to do the division first before it does the multiplication on the bottom. So we need to put parentheses around that, and then we can do math. Oop, nope, don't do math yet. We got to do 3 factorial, 3 factorial times 13 factorial. And then we close those parentheses. So this says to our calculator, do this on the bottom first before you do the division. We push enter, and we're going to get 560. So there were 3,360 different permutations for this option, but there's only 560 different ways we could order them if order doesn't matter. So if we do it that way, we can put it in our calculator that way, or you could do a little bit of algebra first and then just not have to deal with factorial, because remember, 16 factorial divided by 13 factorial, it canceled out that 13 times 12 times 11 times 10. So 16 factorial divided by 13 factorial is just 16 times 15 times 14. Okay, so you could write it like that. And then what is 3 factorial? Well, that's 3 times 2 times 1. So we could do that math and then do it again and we'd get 560. Either way works. Honestly, this is an easier, cleaner way once you get used to it, but this feels more natural at first.